So here we want to find the length of this function 1/8 x squared minus the natural log of x from 1 to 2. We can see here the graph of this function and it's darkened in from 1 to 2, so we want to find this length of this curve. So we know that the length of a curve is going to be the integral from 1 to 2 of the square root of 1 plus, we need the derivative of this function squared. So the derivative here, 2 out in front, that'll make that 1/4 x, decrease power by 1, we'll just leave it x, minus the derivative of the natural log of x is 1 over x. We need that squared, and then dx. So if we can evaluate this integral, we will have that length of that curve between 1 and 2. Now, a lot of these, when you set this up, will have an integral that you wouldn't be able to evaluate by hand. So you're going to see some similarities in these because they are giving you ones that you can calculate here. So let's see what we would get here. So we have the integral from 1 to 2. We can multiply this out, and that would be 1/16 x squared. And then if we multiply these together, the x's are going to cancel and we'd have minus 1/4 twice, so that'd be minus 1/2. And then combined with this 1 right here, that would be plus 1/2. And then last times last here would be a positive 1 over x squared. And all of that actually is underneath the square root, and then dx. Now this actually is a perfect square. It may not look like a perfect square to you, but let me show you how it will factor, and then you'll know to kind of look for things like this when you're working these, because they will set these up to be integrals that you can evaluate analytically here. So we can have the integral from 1 to 2 of the square root of, and this will factor into 1/4 x plus 1 over x squared dx. Now that may not have been obvious to you, but let's check and make sure that you can see that's true. If we square this, we get our 1/16 x squared. If we multiply these together, we get 1/4 for a middle term, and we'd have that twice, so that's 2/4 or 1/2. And then the last one squared is 1 over x squared. So that indeed does work, and they have that set up to be a perfect square so that it'll cancel with the square root, and then this is something that we can integrate. So let's go ahead and integrate that. This is going to be 1 higher power. The reciprocal of the power out in front to multiply with the 1/4 will make that 1/8. And then this one, we can look at this and say what function's derivative is 1 over x, and we know that that is the natural log of x. And then we can evaluate this from 1 to 2. So that's going to be, if we put a 2 in here, squared is 4, so that's going to make that 4/8 or 1/2 plus the natural log of 2. And then evaluating the lower limit, minus 1/8, putting a 1 in here, and then plus the natural log of 1. But of course the natural log of 1 is 0, so our final answer is going to be 1/2, which is 4/8 minus 1/8, so it looks like we're going to have 3/8 plus the natural log of 2, and we can go ahead and just leave this in exact form.